Hello everyone. In this video we are going to study about the depression of freezing point. In the earlier videos we have studied about other colligative properties like relative lowering of vapor pressure or elevation of boiling point. Now this is the third colligative property. So before studying what is this depression of freezing point, let us know what is freezing point. So in the school days we have studied freezing point is a temperature where the liquid gets converted into solid. At that point the temperature is called as freezing point. So that was the definition we studied in the school days. But now the definition is somewhat little bit standard when you come to class 12. That is, freezing point is the temperature at which the vapor pressure of the solid solvent will become equal to vapor pressure of the liquid solvent. So what is freezing point? It is the temperature. It is the temperature at which the vapor pressure of solid solvent becomes equal to vapor pressure of the liquid solvent. To understand this concept, let me take example of water. Consider liquid water taken in a beaker. Now think that we are going to take a thermometer and measure its temperature. Take a thermometer and measure its temperature. For time being, I'll take the temperature as maybe 28 or 30 degrees Celsius. Okay. Now, what we have to do is we have to go on cooling. We have to go on cooling this water. If you cool this water, what happens? The temperature of the water goes on decreasing, and at certain stage, this liquid water, it will change into solid. So liquid water that will get converted into solid, that is ice. And that temperature, it is nothing but 0 degrees Celsius or 273.15 Kelvin. This is the temperature at which that liquid water changes into solid water or ice, and that temperature it is called as freezing point of that water. And you know that freezing point of water is 0 degrees Celsius or 273.15 Kelvin. So this is about pure water and its a freezing point. If you further cool it also, already the water has been solidified and the temperature remains constant, that is 0 degrees Celsius. Further there is no fall, and so that's why this is a constant temperature for getting converted into solid, so it is called as freezing point. Now let me take same amount of water. For example, if I take here 100 ml of water, liquid water, I'll take that same amount of water here, and now I'll add some 50 gram of salt into this one, okay, into this, so that I'll get a solution. Now if you carry out the same experiment, if you go on cooling this solution, now whether you will get the freezing point as 0 degrees Celsius? No. Since we have added non-volatile solute into this solvent, you know that according to the colligative property, relative lowering of vapor pressure, we know that the vapor pressure of the solution is different from that of the vapor pressure of the solvent. So in which vapor pressure decreases? In case of solution, vapor pressure decreases. So here, since vapor pressure decreases, you won't get the freezing point as 0 degrees Celsius. You'll get the freezing point further below 0 degrees Celsius. So we can find out that the freezing point of solution, it is always lesser than the freezing point of the pure liquid solvent. So why is that like that? Or before that, since there is difference between the freezing point of the liquid solvent, that is pure solvent, and the solution, that difference it is called as depression of freezing point, because from pure solvent to solution, the freezing point will fall. So that difference, it is called as depression of freezing point. Now we have to find out why in case of solution the freezing point becomes less. So we know that from colligative properties, in case of solution the vapor pressure decreases. So if I draw a graph of vapor pressure versus temperature like this, you know that as as temperature increases, what happens to vapor pressure? Vapor pressure goes on increasing. That we have studied. When you take liquid and heat it, more and more molecules will be converted into vapor. So vapor pressure is increased when you increase the temperature. But in case of solution, we say that the vapor pressure is decreased. So if vapor pressure decreases, then what should happen to the temperature? Temperature also should decrease in this manner. See, if vapor pressure is here, temperature should be this one. If it further decreases, temperature also decreases. So that's why, since in case of solution vapor pressure decreases, the freezing point, that is freezing temperature, also here decreases in case of solution. So always remember, freezing point of solution is lesser than the freezing point of the pure solvent. But in case of elevation of boiling point, it is reverse of this. The boiling point of the pure solvent is lower than the boiling point of the solution. Okay, that is different. So that is about freezing point and depression of freezing point. And there is a graph which is given in NCERT book, that also you can refer. So see here, this is the graph representing vapor pressure versus temperature, and this is the curve for frozen solvent, this is for liquid solvent, and this is for solution. And this temperature is representing the freezing point of pure solvent, liquid solvent here. Okay, and this is for freezing point of solution. TF is for solution, TF naught is for liquid solvent, pure solvent. And if you take the difference between the two, you will get the depression or fall in freezing point, which is represented as delta TF. So depression in freezing point, delta TF, that is equal to TF naught minus TF. This formula you have to remember. So that is the difference between the freezing point of solution and pure solvent. So that is about depression of freezing point. So always remember, freezing point of solution is lower than the freezing point of the pure solvent. So that's about depression of freezing point. In the next video, we will study how to find the molar mass of solute by using depression of freezing point. Thank you.